Have you ever wondered what it would be like for humans to live beyond Earth? Not just visiting space, but working, building, and maybe one day even vacationing on another world. It sounds like science fiction. But NASA's Artemis mission is the first real step toward making it science fact. In this video, we'll explore the science and technology powering Artemis, and why returning to the moon could change humanity's future in space. Watch till the end, because every piece of this mission connects to something much bigger than the moon. The story begins in the Cold War space race. In 1959, the Soviet spacecraft Luna 2 became the first human-made object to reach the moon. The challenge was set. NASA answered with Apollo. Between 1968 and 1972, NASA launched 9 crewed Apollo missions. 6 landed successfully, and 12 astronauts explored the lunar surface. They brought back moon rocks that transformed planetary science. They tested navigation, life support, and deep space flight. And powering it all was a technological giant, the Saturn V rocket. Why Apollo ended? Apollo ended not because it failed, but because its mission was complete. The political victory over the Soviet Union was secured. The cost was enormous. Public focus shifted toward Earth orbit missions like the Space Shuttle. No human has returned since Apollo 17. Why go back to the moon after more than 50 years? Because this time, it's not about visiting. It's about learning how to stay. It's about the future of humanity in space. NASA's answer to that question is Artemis. Unlike Apollo's short missions near the moon's equator, Artemis targets the lunar South Pole. Why? Because hidden in permanently shadowed craters is water ice, a resource that can be turned into drinking water, oxygen, and even rocket fuel. Artemis is about sustainability, orbital stations, surface bases, and preparing for the next giant leap, Mars. SLS versus Saturn V, power redefined. At the heart of Artemis is NASA's Space Launch System, or SLS. Let's compare it to the legendary Saturn V. Saturn V stood taller, 110 meters, and weighed about 2.81 million kilograms. SLS stands 98 meters tall, weighing about 2.5 million kilograms. But power tells a different story. SLS produces 39.1 meganewtons of thrust, about 15% more than Saturn V's 34.5 meganewtons. It accelerates Orion to nearly 39,500 km/h, compared to Saturn V's 28,000 km/h. Saturn V carried more payload to low Earth orbit, but SLS is optimized for modern deep space missions, with advanced safety, efficiency, and integration. Interestingly, SLS is also quieter. Saturn V was about 2 decibels louder, converting nearly twice as much energy into sound. Artemis is not a single spacecraft, it's a system. Standing nearly 98 meters tall, NASA's Space Launch System is the most powerful rocket ever built for deep space exploration. At its heart is the core stage, about 65 meters high, holding nearly 1 million kilograms of fuel. Inside are 2 massive tanks, liquid hydrogen and liquid oxygen, feeding 4 RS-25 engines that generate over 7 meganewtons of thrust to push the rocket toward space. Helping it lift off are 2 solid rocket boosters. Each stands 54 meters tall and burns solid fuel that can't be shut down once ignited. Together, they produce an incredible 32 meganewtons of thrust, providing most of the power during the first 2 minutes of flight. After the boosters separate, the interim cryogenic propulsion stage, or ICPS, takes over. Powered by a highly efficient RL-10 engine, it performs the critical burn that sends the spacecraft from Earth orbit toward the moon. Connecting everything are key structural adapters, the LVSA and Orion stage adapter, which transfer loads, protect upper stages, and separate Orion at the right moment. At the very top sits the Orion spacecraft, designed to carry astronauts beyond low Earth orbit. Its crew module protects astronauts during re-entry, while the European service module supplies power, oxygen, water, and propulsion. And above all of it is the launch abort system, ready to pull the crew to safety in milliseconds if anything goes wrong. Together, these components form Artemis, NASA's pathway back to the moon and beyond. Artemis 1 flew uncrewed in 2022, A flawless test. Now comes Artemis II, the first crewed mission beyond low Earth orbit in more than 50 years. The international crew includes Reed Wiseman, Victor Glover, Christina Koch, Jeremy Hansen of the Canadian Space Agency. Here's the mission timeline. At liftoff, 4 RS-25 engines ignite, joined by 2 massive solid rocket boosters. After 2 minutes, the boosters separate and fall into the ocean. The core stage burns for about 8 minutes before separating. The ICPS then places Orion into high Earth orbit. For 24 hours, the crew checks life support, communications, and navigation. Then comes translunar injection. A precise burn accelerates Orion to nearly 40,000 km/h, sending it toward the moon. After a 4-day cruise, Orion performs a close flyby, passing about 7,400 kilometers above the moon's far side. Lunar gravity then slingshots the spacecraft back to Earth. Re-entry occurs at Mach 32. The heat shield withstands extreme temperatures. Parachutes deploy, and Orion splashes down safely in the Pacific Ocean. Artemis II proves something critical: that humans can survive. Deep space radiation, long-duration missions, navigation far from Earth. It sets the stage for Artemis III, a future landing at the moon's south pole, followed by sustained human presence with gateway and surface habitats. Conclusion: the big picture. The moon is no longer the destination. It is a proving ground, a place to learn how to live beyond Earth before humanity reaches for Mars and beyond. Artemis is not about repeating history. It's about building the future together. If you enjoyed this deep dive, like the video, subscribe for more space mission explainers, and tell us in the comments, which part of Artemis excites you most: the crew, the moon, or the road to Mars? Thanks for watching. And as always, we'll see you among the stars.